And then go ahead and try and do B and C also, once you've got that. Okay, Nick, what's our input?
That's the amount of couches.
Uh-huh, and what do we use to represent that? Good. So when you do all this listing stuff, the key to be able to use that later on in the problem is that you write it in words, and that you also like say what variable you're using to represent that. That way, anytime you find an X, you can go back and be like, oh, X was the number of couches. Anytime you find a C of X, you can be like, oh, that was whatever it is. I haven't asked you guys about that yet. Cole, what's the output?
Is the output just total cost?
Uh-huh, and what do we use to represent that? Good. So C of X. Remember that this entire thing represents your output. So like that whole thing is a variable. C itself isn't a variable. It's just the name of the function. C of X tells you the cost related to X couches. So again, we express both the input and output in terms of words and in terms of algebraic symbols. That way we can go back and use that information later on. Anytime you find an X value, you know what it means. Anytime you find C of X, you know what it means. So then on this graph, let's see, where am I? Brett, what is the lowest possible monthly cost?
To be honest, I didn't really figure that out.
Okay. Well, do you see the point that's going to give us the total monthly cost? Or the lowest? What? Sorry?
Is it the length?
The length of what?
The point? I'm not sure if I understand this entirely.
So, well, we have an input and an output, right? So, like, our horizontal axis represents our input or our output.
Okay.
Which one? Katie? Input. So that's going to be the number of couches. And then the vertical axis, so the y coordinate, Elijah, what does that represent?
The total cost.
So that's always our output. So do we see what point is the lowest point? Like, and we don't need to overthink this. Like, it's visually, like, for real, the lowest one. So it's the one where I put a dot. So this is the ordered pair, right? That's an X value and a Y value. So which one of those, Madison, which one of those is going to be my cost? The 150 or the 275? Yep. So the lowest cost is what, Brendan?
$275.
$275?
Yes.
$1,000, right? So that's another thing that it can be handy to put up here, like right in thousands, if you find yourself forgetting that part. Because it's easy to kind of get going with the problem and like forget about that piece. So if it helps, or if you find yourself forgetting it, just put that with your statement of what the output represents. So the lowest possible cost is $275,000. And then Peyton, how many couches should be produced to minimize the cost?
150 couches.
Uh-huh.
Yeah, I thought this was a lot harder than what it was. I thought you had to somehow put something back in the equation, figure out a different number.
Well, so, I mean, that's the thing about all of the problems we do. don't try to just like be like, oh, that one time we put this number in this equation, right? Like, ask yourself what it's actually asking you and what you have, right? If you label your axes and you have a point, and then you can say, okay, so this is couches and this is cost. Then when they ask for the cost, you're like, hey, look, I have the cost, right? And if they ask for couches, you're like, hey, I have the couches. The reason on this one that we had to plug something back in was because when we labeled everything, we said that point gives me a length and an area, and what I'm being asked for is a length and a width, right? So the point didn't give me the things that I was being asked for. But again, that's why we label everything, because once everything's labeled, whatever we're asked for, we can be like, hey, do I know that? Like, is that in my point, right? Like, sometimes it is, sometimes it's not. It just depends on the function. That makes sense? Okay, let's do this. These problems will never go away. Okay, so we've done part A and B before. They were on your first test, right? So like the price changes as the quantity changes. So we're told here that the price per person goes down by 25 cents for every one person above 30. So if there's 31 people, that's going to make this like $9.75. And this is, apparently when I printed, I did not hit control the first time I printed. So this is, there's no P there. That's, I hit the P to print. Yeah. And I didn't notice in time. Yeah, it's
Really
300.
trying to figure out what to put in there for P.
What?
I think you were saying that that's at like 0 people.
No, yeah. That's why I corrected. And we can ignore this for now. So we're just looking at quantity and price for now. So then my price for 32 people would be $9.50. And then if there was 40 people, well, from 30 to 40, my quantity went up 10. So how much would my price go down? $2.50, right? I have to lower it by 25 cents 10 times, right? Because for every one person increase, my price goes down by 25 cents. So from here to here, I have to go down by 10 times 0.25. So that makes this like $7.50. Be careful when you do those that you're measuring from. I mean, we could measure from the 32. We could be like, I went up 8 from 32, and then I'd have to go down 8 times 0.25 from 950. I just think 30 and 10 are easier numbers to work with. But just be sure that you're really clear about where you're starting so that you don't like subtract 250 from 950. Right, we have to subtract it from the 10 because we measure the quantity from the 30. Does that make sense? Okay, so now we want to write a linear equation that models the price if X people are on the tour. So X is our quantity. And I'm going to call P my price. One good tip about all of these problems is to never use the variable y, only because if you use y here, then we get to this graph and we start thinking that the y value of this graph represents something different than what it represents. So if I have to make up a variable, I just don't use y because it could turn out that that's not actually like the y coordinate on my graph. So I'm just going to use p. So we have 2 points. 30, 10, and 31, 975. You can either get the slope using the slope formula from those 2 points, or you can notice that it tells us that as the input goes up by 1, the output goes down by 0.25. That's the definition of the slope. The slope of a linear function is the change in your output when your input goes up by 1. So they tell us the slope right here. If you don't realize that from reading the problem, again, that's totally fine. You can just use 2 points to get it. Once we know our slope, we're going to use our point slope formula. So we have our slope is equal to, so the slope between, so it's the change in our y values. I'm going to use 30/10. So change in our y values over change in our x values. Right, that's just our slope formula between the point that we know and a general point xp. And then we'll clear fractions. You guys remember this? Yeah? Things that we did before aren't going to go away, I promise. So equals p minus 10. So we'll distribute, that's 7.5. I'm sorry, I ran out of room. Equals p minus 10. So we get p equals negative 0.25x plus 1750. So far, so good? Now we want a function for our revenue. So that's what we're really trying to get to, is a maximum revenue. I'm just going to write this 0 again. Here we go. So in general, revenue represents the total amount that you collect from like selling something or performing a service. So if you know the price of each item and you know the quantity of items that you sold, how would you find your revenue? Like if I sold 10 t-shirts for...
Multiply the quantity and price.
Yeah, right? If I sold 10 t-shirts for $5 each, I made $50 off of them, right? So you multiply the quantity sold by the price per item to get the amount of money that you brought in. Revenue has nothing to do with like net gain or loss. It's not profit. It's just like the actual amount of money that you collect. So this is quantity. Whoops. The general formula for revenue is always quantity times price. So we can fill out the rest of that table just by multiplying the first 2 columns, right? So 30 times 10 was 300, 31 times 9, 75. You guys, I'm doing this from memory, so tell me if I mess it up. Is I think 302.25. And then 32 times 9, 50 is 304, yeah? And 40 times 750 is 300. One thing that I notice immediately, like even if I wasn't looking ahead, is that this isn't a linear function, right? Like it seems to make sense that if we sell more, that we will make more money. But remember that the price goes down as the quantity goes up and vice versa. So there gets to be a point where the price is so low that even selling more isn't going to overcome the price change. And so that's why it goes down again. So any function so we started at 300, then we went up and then back down. Any function that goes up and then down can't be linear, right? Because a straight line can't ever turn around. And so we see immediately just from that the values in the table that this is the revenue function is definitely not going to be a straight line, right? So I point that out because that means we can't use the same ideas that we used in part B for part C. Like you can't find the slope of a nonlinear function, and you can't use the point slope formula to write the equation of a nonlinear function. Those only work for lines. However, we do know that revenue is quantity times price. And we have X is our quantity. And this tells me that I want everything in terms of that quantity, right? That when I write this revenue function, the only variable on the right side in that formula is X. So initially I would be like, okay, I want R of X to be quantity times price. And I could be like, okay, well, I said up here that quantity is X, right? So over to the right here, I said X equals quantity. And then I said that price is P, but then I run into an issue because I have two variables on the right side and I only want one. Like, you can't have two variables. But that's why we did this whole bit, is because we have an equation that tells us how to find our price if we know what X is, right? So this whole expression represents my price. And so just like we did before with the length and the width, this problem, it looks really different, but these problems are actually identical to the area problems. Like, you have an input, and then you find your other unknown in terms of that, and then multiply them together to get the function. Just like we did with the area. So R of X is going to be equal to X times that whole entire expression for our price. So negative 0.25x squared plus 17.5x. And again, I cannot emphasize enough how important it is to just label everything in sight, because most of these problems are really just like some sort of substitution is like what we do for the most part, right? We substituted for P, but it can get really confusing if you don't know what everything represents, because it's hard to substitute for things if you don't know what to use to substitute, right? But if you label your price and you label your quantity, then when you write quantity times price, all you have to do is look for the word quantity and look for the word price up in our labeling. So now we have a graph, and I want you guys to do part D based on that graph. That is the graph of the revenue function. So the function that we just came up with, R of X, that's the graph of it. Be sure you label first. So if this is the revenue function, what's the output of the revenue function? So what is the revenue function calculated? Why do you think we call it a revenue function? Because it gives you the revenue. Yep. So the output of this function isn't the price, right? It's the revenue.
Okay.
That's why I didn't call P. That's why I didn't call this Y. Because then it gets really confusing down here, because it makes you think that this is your price. What they want isn't necessarily what that point, right? question and like, and say, oh, they want the number of people or they want the price, read back up to the top and see if you can find the word price or quantity somewhere, right? Because usually you set it up in such a way, if everything's labeled, you've set it up in such a way that all the information you need is there, right? If you just look for the words. Is that an 8?
Yeah.
Okay, good. Just making sure. It looked like a 0 for a second. Right. So what is it asking for? Is it asking for quantity and revenue? Right. Once it says determine the price and, so you gave the price, yeah, there you go. And then write a sentence. Oh, it's almost time. So I'm going to start by labeling this, right? So the input of this function is what? Sorry? Yes. And what's the output? Revenue, very good. So that means that this is the number of people. And this is my maximum revenue. So now that I've labeled everything that I have, I'm going to look and see what it is that I want. Well, it says determine the price and number of people. So I know the number of people. That's 36. But then the price I don't know. So that's when I go back up and I say, okay, do I see the word price anywhere? Well, here's price. That's P. And I have an equation that says P equals based on X, right? So if I know X is 36, part B tells me how to find P. So I just plug it in. So X equals 36, P equals negative 0.25 times 36 plus 1750, which is 850. And so revenue is maximized with a group of 36 people at $8.50 per person. Okay, so your homework tonight is basically